Welcome. I'm Aaron Fulkerson, CEO of OPAQUE Systems. Here at OPAQUE, we work with enterprises that are trying to run AI on their most sensitive data. That's a harder problem than it sounds, and it's the topic that we're going to be digging into today. The question that brought us here is simple. Where is your AI stack bleeding data? Turns out it's bleeding data in a lot of different places, and it's not because somebody's hacking you. It's because that's actually how AI architectures work. And the answer, once you see it as to where it's bleeding data, really changes how you think about AI as a secure mechanism. That doesn't mean that you can't secure it. We're going to get into that in a moment. But by default, these systems are really leaky with your proprietary data. So I brought somebody on who's built a framework specifically for finding the leaks, someone who spent years at Marsh Insurance underwriting cyber risk and now runs AI governance audits for regulated enterprises. His name is Adam Gladsden, and I want to introduce him before we get into the content. Adam Gladsden is the founding partner of Broad Street Labs and the co-founder and CEO of ConfigRisk Group. Before Broad Street Labs, or BSL, Adam was the senior vice president of cyber risk at the cyber risk product at Marsh, one of the largest insurance brokerages and risk advisory firms in the world. He spent years there at the intersection of cybersecurity, insurance underwriting, and emerging technology. He's built the trusted AI audit framework to help regulated enterprises pinpoint exactly where their AI systems leak and map that to their regulatory and insurance exposure. The EU AI Act, NIST AI, RMF, HIPAA, DORA, all of these are emerging or regulatory requirements that are already in place that Adam knows and cares deeply about. He's a licensed cyber insurance broker with a Wharton MBA. He knows this problem from the underwriting side, the governance side, the technology side, and the client side simultaneously. So Adam, thank you so much for joining us today. Welcome.
Yeah, my pleasure. Thanks for having me.
Well, Adam, let's just dive right in. You came out of Marsh, one of the biggest insurance companies in the world, and you built this AI audit framework. What made you decide this was the problem worth your time?
Yeah, so thanks, Aaron. It was interesting. While I was at Marsh, my job was to design and build cyber risk products that helped model and quantify cyber risk exposures for our clients. So until recently, cyber underwriters were trying to quantify exposures that didn't have much actuarial history. They were using questionnaires that were already a generation behind tech. They didn't have a lot verifiable. They've kind of caught up, but clients started to ask questions about their AI risk exposure, and it was following a similar pattern, right? So as they started to scale, they wanted to understand, beyond pilots now, and as you're looking at ROI, what should we be focused on? And so things were happening, though, at a much faster pace and with much higher stakes. So the tools that security teams were using weren't built for how AI systems were actually handling that data. And the governance frameworks that were being used didn't really map, at least cleanly, or if at all, to these risk vectors specific to AI. So you combine the regulatory pressure of the EU AI Act, DORA, NIST AI, RMF, and all of it landing before most organizations had any method for assessing this actual exposure. So with all of this, the risk is growing, the regulatory clock keeps moving up. You've got state patchwork frameworks here in the US, you've got executive orders on the federal side. So there was a lot of confusion, and there really wasn't any sort of framework to map all of the regulatory and insurance exposures to AI leakage vectors. So that's really where I saw the opportunity to jump in here and tackle it.
The world's changed so much in the last, year, last 6 months. In 2025, I'd talk to large enterprises and I'd explain to them, your AI systems, they're bleeding data all over the place. And they'd be like, what are you talking about? That's not the case anymore. It's very clear to organizations, and you're working with a lot of large and regulated enterprises right now. What's the common thing you're seeing that surprises you, the gap between what organizations think they have and what's actually there?
Yeah, it's the most common thing, and I think it's around shadow AI, right? There's both the concern and the reality of that, the concern that organizations have of how are their employees using AI that either hasn't been approved and what data is exposed around that. And then the thing that was surprising to me is really how wide the gap is, how much organizations think they know where AI is operating in their environment. They have an approved AI stack. They've got policies in place. They're reviewing the tools. And then we'd go in and run an audit to find that employees were in fact using personal accounts to process client data, browser extensions with AI features whole ton of SaaS products that had all sorts of AI capabilities that just weren't accounted for, right? Within the governance framework, the governance structure, or the policies or procedures in and around those. So it's really just having that lack of visibility into the inventory that's really the problem there. But how large the gap is and how consistent it is amongst organizational size. It doesn't matter if it's a large enterprise or some SMBs, that problem is consistent that we've seen amongst our clients, and the gap is pretty wide. So I was pretty surprised around that.
So the fundamental shift here is that we're going through a technology platform shift that is unprecedented in human history. You see these platform shifts, they occur, every 10 or 15 years or so. An example of what I mean by a technology platform shift is the internet, right? So the internet changed everything about how business operates and how our society functions. But whenever you do these technology platform shifts, you have to go through a trust layer upgrade. So I'll use the example of the internet. During the time of the internet, in order for it to become at the dawn of the internet, before it could become a software delivery platform or an e-commerce platform, we had to upgrade the trust layer. So specifically, that was through SSL certs and a TLS layer that created encryption of data in transit. Now, for probably everybody on the webinar, we're probably all aware of the days when you go to a conference and you get on the public Wi-Fi and people would be able to immediately access your logins and passwords because these were open networks. They weren't encrypted channels. Effectively, the same thing's happening with AI right now. These systems are inherently leaky. It is very easy for people to lose their proprietary information or violate regulations. And the mental model I like to use is, imagine you're writing a confidential letter, but if you're using modern AI systems, you're writing it on a postcard. And that content is private in intent, but every person in the mail sorting facility can read it as it passes through. So your AI systems work exactly the same way. Your data is private in intent, but the architecture exposes it through completely normal operations to your observability tool, to your application performance monitoring, to your cloud ops team who's managing your infrastructure. It's not because anything's wrong has occurred, and it's just how inference works as part of the AI workload. So I thought it'd be helpful just to introduce this concept, because what we found through our AI data leakage surface mapping, it happens across 3 layers. There's the platform layer, which is the compute infrastructure. This is actually your hardware and Kubernetes layer. Then there's the workload layer with your agents and models, and the application layer. So I'll give you some examples. I'm not gonna give you all 46 exposure vectors. I'll give you a few. One is just as part of a routine capacity audit on an AI cluster, the cloud ops or DevOps engineer commonly run standard memory dumps so they can plan capacity appropriately. When they do that, it captures all of the live inference. So if you're, let's say, a regulated industry, that means all of your client portfolios, social security numbers, investment strategy. That means everybody in your infrastructure team has access to all of the information that is regulated and private, which for investing purposes, if you're inside of a financial services firm, could literally be strategies related to moving and changing stock markets, right? At the very least, it's violation of regulations, because none of them are authorized to have access to this. But nothing's broken, right? It's just how inference works. Let's talk about the control plane. This is where the actual agents operate and make decisions. I'll use a similar example. If we're talking about the insurance industry, we work with companies in the insurance industry that have agents that help them detect fraud. Now, in that scenario, the chain of thought, which is the agent's intermediate reasoning, contains everything from account numbers, social security numbers, name of people under investigation. Those traces are commonly shipped to an observability platform for debugging data. That means that the entire team with access to the observability tool, which could be a third-party service that's hosted like Splunk or Datadog, can read all of that regulated information, including contractors that aren't covered as part of your data processing agreements. Moving up the stack to the application layer, or even the intersection of these trust boundaries, SOC 2 says you're compliant across all of these, but DORA, which is already enforced, and the EU AI Act, which is coming into enforcement in August, deadline requires that you have proof of the data that was protected at the time of processing. So you have to have runtime attestations of what was processing the data, what does the stack look like, not deploy time, not audit time, but actually at the time of execution. And today, unless you're using some of these new modern technologies that are doing attestations that we'll talk about in a moment, you have no way of knowing that. So the full report, we actually have a 3-pager available for people who are interested at OPAQUE that map out these exact dozen with specific examples, but the full report maps 46 of these across 8 categories. This work was informed by our customers and design partners at Anthropic, ServiceNow, Accenture. It's been validated by more than 200 enterprise AI leaders and also with our technology partners at NVIDIA, Intel, AMD, and Microsoft. So Adam, your framework is built to specifically find these data leak vectors. Let's go deeper, and I'd like you to walk us through how your trusted AI audit actually works.
Yeah, absolutely. So yeah, there's a very nice overlap here between OPAQUE's view of seeing how you bleed data and what we're doing in the AI audit, and what we're looking for. There's a complementary factor here. So the problem I kept seeing was that organizations would come to a renewal or an advisory engagement with a clean SOC 2, reasonable, acceptable use policies around AI, and genuine confidence that their AI risk was under control, right? But then when we looked in the actual environment, what the models were actually trained on, what was flowing to third parties, external partners, what the inference logs contained, the picture was completely different from reality. So, and similar to, when they fill out a cyber insurance application, it's not a matter of being dishonest. It's what they believe and what they understand and what they know, right? So because the audit frameworks and the security tools weren't built to look at what AI actually does with data, they were built for a different problem. And so the trusted AI audit framework is our answer to that gap, right? It examines 4 domains in parallel. You can see those in front of you: infrastructure, model and training, application integration, agent orchestration. And it produces a single output, a prioritized risk map that sequences every finding by regulatory exposure, not based on technical severity, but so that the CISO and the compliance officer all get the same document. Everyone's on the same page. And I think that's something that even on the security side, we're not seeing a lot of here, right? So there's an opportunity to kind of bring all parties to the table here, not only based on function, but based on use, complexity, and responsibility, right? Which spreads more across the organization than I think we even see with security. So let me walk you through what we actually look at. So first domain, infrastructure layer. This is one that looks probably most familiar, especially to security teams. And you're really looking at storage, access, and telemetry, right? Your security teams know what cloud storage reviews look like. They know identity access management, bucket policies, multi-factor authentication, right? They've done this work before. What they haven't done is run it through an AI lens. And I think that's where this gap is, right? Right? That lens changes what you're looking for. So we'll go in, we'll look at an S3 bucket, in that context. And we're not just looking about, who accessed the data. We're really looking about who can access the model weights. The model weights aren't just a file. It's the settings, of the model's brain, a compressed representation of what it learned through training. And under the right conditions, deep models can memorize and later reveal some of those rare training examples, which could include sensitive data like credentials or identifiers, right? So that doesn't mean every model is constantly spilling secrets, far from it. But it does mean that companies need to, treat production weights as if they might encode sensitive data, right? Especially when they've been fine-tuned on proprietary corporate data. So that's a different threat surface than your team's been reviewing. And it almost never shows up in a traditional audit. So same thing with logging. Most orgs have solid logging, on their traditional infrastructure, but almost nothing at the AI inference layer, right? So there's no record of really what went into the models and what came out or who triggered it. We map every AI related network flow, every touch point where AI connects a data system. So in most environment, these maps have never been drawn. A lot of times they're not drawn on the security side either, but it's critical, especially from a governance perspective here, without having a lot of other policies in place to be able to do that mapping. So the framing I use for this domain, same discipline, different lens. the gaps are rarely in the methodology, it's really in scope, right? So second domain, this one we're going to dive a little bit deeper on. This is where the audit really diverges sharply from anything in traditional InfoSec. So this is where we see kind of the highest regulatory exposure, especially in financial services. So this is really what the model absorbed. So we start with kind of data composition. Is the model trained on sensitive data? PII credentials, proprietary information. It's not a hypothetical concern. Sensitive data is absorbed during training. It doesn't inform the model's behavior under certain attack conditions, but it becomes recoverable from the model weights after the fact. So the attack class has a name, membership inference, applies to production models running today. So there's fine tuning and continuous learning. This is where AI breaks from everything traditional security frameworks were built around. Legacy frameworks, you assume, deploy a system and it's static and you patch it. AI doesn't work that way. The models that incorporate the fine tuning, it's constantly given the human feedback, ongoing training cycles, which means the policies have to address this continuous update motion, right? Not just what was deployed last quarter. Governance frameworks haven't caught up to that yet. So, again, the intent here is not to do anything but expose findings, right? And put you on a path for being able to be more secure, understand that exposure, and so that companies like OPAQUE can come in and give you the verifiable component to that. So we actively test for memorization, not just review policies. We kind of probe the model directly to see whether it can be prompted to reproduce training data. A policy might say, we don't train on sensitive data. This is a big point here, which is not the same thing as evidence that the model isn't memorized yet. So those are two entirely different assertions, excuse me. On the RAG side, we look specifically at whether document level permissions are enforced at retrieval time, not just at ingestion. And this is a key point to make, especially around access. One of the most common findings we bring back is around the access control of documents in and around prompting and retrieval, right? So something to consider. Application integration layer. This is the third domain. This is one most have started to think about, right? Third party and provider risk. Companies of all sizes are wondering what's been sent to LLM providers, right? What gets retained for their training? We review every provider agreement and every engagement. So on the healthcare side, the business associate agreements, data protection agreements with regard to GDPR, opt-out configs, things like that. So we'll do that mapping to understand what agreements you actually have in place since they have drifted from their original intent, which may or may not include AI. So context window overflow in a shared wealth copilot. It causes clients trade off on P&L path surface as pure examples. Another client recommendation. There's no hack, as Aaron mentioned. There's no hack, there's no alert, just normal use of an AI tool with bad context engineering. So the framing I use here, this is the right place to start. Most companies do. But orgs that treat this as sufficient coverage are carrying unexamined exposure, in the other three domains, and that usually don't find out until a regulator or an underwriter asks a question that they can answer, right? So the last one, this is really around shadow AI and agentic risk. This comes back to the conversation, Aaron, that we had earlier. Shadow AI is where almost always we find the largest inventory gap, not because employees, again, aren't doing anything rogue, but because every major SaaS vendor has shipped AI capabilities in the last 18 months inside tools that orgs, already licensed, but really don't have peering into. So document management platform, CRM, collaboration tools, features that activated by default are now processing sensitive data under provider terms that nobody really revisited. So I've got a stat here. LayerX did a study and found that 18% of enterprise employees are regularly pasting corporate data into Gen AI tools. More than half of those pastes include sensitive information, so that's pretty telling. Agent memory is an area that we flag as most significant for where enterprises are heading. Agentic systems generate agent-to-agent communication. We all know about agentic, but the logs, the traces, the metadata, they can be rich in sensitive workflows and decision logic without anyone ever directly accessing the underlying data. So most orgs have no monitoring on this layer at all. So the way I frame it here, your security team has reasonable visibility into how humans interact with AI. Almost none of them have any visibility into how AI systems interact with one another, right? So as these agentic architectures scale, that blind spot scales with them. So when the audit is done, we produce across all four of these domains a prioritized risk map, as I mentioned at the start, not a findings report, not a maturity score, right? A sequenced picture of where your regulatory exposure is the highest, uh, what can be closed in the next 30 days. We give you that roadmap through configuration work and what requires an architectural decision. So a lot of policy-driven work can be done in those first 30 days. And again, this is something that the CISO compliance officer, they get the same document, technical findings already translated into the regulatory and insurance language that each of them need to act on. So with that, Aaron, I think I got it covered. I'll turn it back over to you.
Thanks, Adam. You talked about the security teams, right? A lot of times security teams think that data loss prevention and access control have this covered. What's the real gap here between what they think they have and what your audits actually reveal?
Yeah, interesting. The gap's not really about investment or intention. I think it's a mismatch between what these tools were actually built to do and what AI actually does. So yes, there are DLP tools that are built into some of the frontier models, right? There's a really foundational, if you use them in conjunction with these, they're much more effective. But DLP was built for structured data movement, right? It looks for known data signatures. So it programmed for social security numbers, credit card patterns, PII format, things like that. And it's excellent at catching data exfiltration, right? But it's essentially no capability against leakage specific to AI because those vectors don't look like exfiltration. They look like inference, right? So there's no boundary crossing. There's no alert. It's really doing what it's supposed to do. So it's moving through normal operations. Think of DLP as a customs checkpoint looking for contraband. AI leakage is like osmosis, data moving through the membrane of normal AI operations without triggering any checkpoint because it was authorized to be there, right? So nothing broke, no rule was violated, the data still left, right? Here's what we do find in practice. I mean, think about a mid-market bank. You had the example earlier, Aaron. Mid-market bank running an AI fraud detection agent. The agent's chain of thought reasoning, the immediate steps it produces to reach a decision, contains account numbers, investigation flags, names of individuals under review. The chain of thought gets shipped to an observability platform as debugging telemetry. And so you've got engineers that can read it, including contractors, right? DLP didn't trigger because the data moved through an authorized logging channel. Access controls didn't trigger because the engineers are authorized users of the platform, right? So everything worked correctly and the data was fully exposed, right? So, IBM did some research in their cost of data report that 90% of orgs that experience breaches tied to AI lack proper AI access controls because it didn't have that complete flow through, with 63% having no AI governance policy at all. These aren't surprising stats. I think it's just the reality of where we're living, that we need to do more and think about it differently.
Yeah, it's the Wild West. Everybody's in their
Yep.
charge to get 10x, 100x productivity from AI.
You know it.
They don't. It's like, well, I don't have to be faster than the bear. I just have to be faster
Yeah.
than everybody else. And I think the bear
Right.
is going to eat that bigger guy
Yeah.
before it eats me.
Yep.
So you came from Marsh. You've got a lot of experience in this. When an underwriter is evaluating an enterprise AI stack, what evidence actually satisfies them? What does proof look like specifically? I know this is changing, so tell us a bit about that.
Yeah. So it's interesting. AI as a whole, as a risk category in insurance, it's obviously burgeoning, right? It's still nascent. And it's exactly where cyber was 5 to 7 years ago. But I mentioned earlier, the pace of change is really daunting, right? So the underwriting standard for AI is being built right now, right? It's being designed right now. The direction is clear, even if, the final form is far from what it would be. So when I was in March, I watched, cyber go through the exact cycle. AI is on the same trajectory, compressed into a much shorter window. You're seeing exclusionary language that's happening within coverages right now. You're seeing a few companies that have launched the first standalone policies within AI. They're focused on model performance, liability on output, things like that. But really, it's in flux because they're trying to figure out what coverages actually need to look like. And so from an underwriting perspective, the focus really now is on the governance framework itself. So in lieu of telemetry data, which is really lacking, what can they do? So they're looking at these policies and procedures. What kind of structures do you have in place? This is where this audit framework really helps on the insurability side to show that you have guardrails in place, right, in and around the data leakage, right? So you have a peering into data leakage, you have a peering into inventory, you have a peering into what should be, what good should look like. So at least you have that fundamental understanding. That's really what they're looking for. It's really, you know, they can hand an underwriter a SOC 2 and a policy document and say they're compliant, but the fact is, for AI risk, the window on that being sufficient is closing. They need to do more. That's where governance comes into play.
So Adam's described where policy and documentation can't close the gaps, particularly with EU DORA that requires runtime verification. These guardrails that are running inside of these AI systems are also non-deterministic. There's no way in standard deployments to verify that the guardrails were fired or the policies were enforced during runtime. However, there is an emerging category, which is the convergence of two design principles. The emerging category that Gartner's writing about now is called confidential AI. This is the convergence of this collection of standards bodies, for example, these technical standards that are provided by IETF or NIST around remote attestation procedures, entity attestation tokens, and existing policy as code frameworks like OPA, converging with the silicon vendors who all have released and have been investing in a category of computing called confidential computing. So this is Intel TDX, AMD SEV, NVIDIA H100s, ARM. Everybody has a confidential computing capability as part of their silicon. Why is this relevant? Because the convergence of the standards around attestation and this new hardware allows companies to deploy confidential AI that provides hardware enforcement of policies that are provable. And here's how this works. Every layer, from the silicon to the infrastructure to the workload graph, which could be an agentic workflow, all gets cryptographically stamped from a hardware attestation from the actual silicon, from AMD, Intel, NVIDIA, one of these providers. It gets stamped and creates a cryptographic signature that becomes the identity of that workload. Now, what that means is before you send your data, you can ask for the identity of the workload and say, oh, okay, I see. It's going to enforce all of my policies. And I know it's going to enforce it because they're cryptographically bound into the runtime. So the hardware itself forces the policies and the guardrails and the privacy of your data during execution. And as a result, what that means is after the workload executes on your data, you know your data is kept private. The vendor cannot even see the data because of properties of confidential computing. All of your policies are enforced, and you can mathematically prove it. You can say, give me the signature. Let me actually prove that the guardrail's fired. Let me prove that you used my user identity, that you enforced RBAC, that you enforced purpose-based access controls, that you didn't leak PII or PHI through agent memory or session state somewhere in the stack, that some observability tool that you sent the logs to can't now peer into my data and see PHI or PAI. You can prove all of this, independently verify this through an attestation report. So this is the emerging category that solves this problem. So if you go back to just the 12 examples of the 46, all of them are either solved or mitigated. All of them are through this concept of confidential AI. So again, this is as is always the case, the emergence of open standards in hardware open standards in cryptography that make this category possible, allowing companies to deploy AI with confidence. So you put these three things together: confidential computing, RATs, EATs, and OPA policy enforcement. This 46 vectors get solved or mitigated, all of them. So it actually means that in some scenarios, like you see right here where they're greened, it's impossible for those leaks to occur. It's physically impossible because it's enforced at a hardware level. So the slide title really says everything here, which is this isn't a bunch of patches within your AI infrastructure. It's one architectural change that solves this problem. So Adam, I know that you know a lot about this. The format that makes this machine verifiable with open source tools for the auditor, they don't even have to trust the vendor. Like they don't have to trust OPAQUE or other vendors that are taking and using these categories. How does this evidence solve, or what does this change in your world for your practice?
Well, it's interesting, Aaron, because I spent the last 5 years at the intersection of telemetry building within the insurance industry and those ecosystems, right? Of how do you get to a trust but verify component with cybersecurity signals, right? How do you bridge the gap between attestation on an insurance application, what actually is happening behind the scenes? OPAQUE is solving this problem initially with AI, right? Because especially in a world without formal telemetry data, providing that evidence closes that gap. So now it's, here's the governance that we have in place that you can attest to. And okay, now you have a tool like OPAQUE that can actually show that the controls are in place and how they're working, right, in a verified capacity. So bringing those two together, that's a powerful solution, especially on the insurance side, right? But even from an auditability perspective, it's beyond just a theoretical and puts it into practical terms.
Thanks, Adam. So Adam's framework tells you where your AI stack is leaking. We also have a 3-pager and a report we'll be publishing later this year on all 46 vectors. The 3-pager has 12 of them. Adam's able to map your leaks to your regulatory obligations. The standards ecosystem we just walked through tells you how to prove these leaks are sealed with cryptographic evidence that any auditor can verify, which is actually a requirement of some of the new regulations that come out in August of this year in Europe. So this is workflow diagnosis, standards-based remediation, independently verifiable proof. Reach out to Adam at Broad Street Labs to book a trusted AI audit with Broad Street Labs. If you'd like to see an attested evidence pack of verifiable policy enforcement and provable privacy, reach out to us at OPAQUE and we'll be happy to share it with you. We are over by 3 minutes, but we have some questions. I'm going to grab a question from the chat. Right now, all of our AI policies are human readable documents. From your perspective, what's the right way for an enterprise to start turning those into enforceable machine readable controls? I'll take a quick stab at them and I'll turn it over to you.
Sure.
There are multiple standards from ORDL to OPA that you can convert human readable contract terms into actual cryptographically enforceable and verifiable policies from your AI runtime. So there's actually a mechanism for doing this using open standards that are hardware attested as part of a confidential workflow and then verifiably enforced during your AI runtime. That's a great question. Adam, did you want to tack anything onto that?
Yeah, I would just say this as part of our exercise, we would take those formats and we would actually do the mapping to the regulatory framework, right? So we would look within the specific articles of those frameworks. That would be part of that output, where then from an auditability standpoint, you'd see where that linkage is, right? And where they apply and where there's any gaps.
Yeah, I think I said ORDL. I meant to say ODRL. I always get those mixed up. Thanks, Adam, and thank you all for attending. We're 5 minutes past, and I want to give you all freedom to get back to work. And thank you for joining us on this Thursday. Have a wonderful day.
Thank you for having me, Aaron. Take care, everyone.
Thank you, Adam.